Today, this is the first session of our webinar series, which we are conducting as a part of DESIGNSPIRE 2025. So, as all of you know, and if you are not, I can say, familiar with this program, so DESIGNSPIRE 2025 is basically a initiative by Ilustraca YouTube channel and Ilustraca Academy. So this year our theme is building design. So we are conducting a competition among the students and fresh graduates, and we have given them the plans, those who have registered till now. The registration date is still there up to 31st March. So you can visit our website www.illustrator.in/designspire, where you will be getting all the information regarding this initiative. So uh, as a part of this initiative, we are also conducting webinars with the experts in the industry. So this is our first webinar, how to begin your bridge engineering journey with engineer Vikram Singh. So uh, I will just give you some introduction with the DESIGNSPIRE. Already I have told you about the DESIGNSPIRE. So we have the respected jury members, Dr. 𝐀𝐩𝐩𝐿, Dr. Engineer Kunal Talsania sir, Engineer Nirav sir, Engineer Deepa ma'am, and Engineer Kulbhushan sir. They are the experts in the industry, working in the industry for a long time, and they will be, you can say, judging our the submissions that the students and the, you can say, participants will be submitting in this program. Okay, so today we have engineer Vikram Singh with us as a guest speaker. And actually, Vikramji doesn't require any introduction. All of you must know him because we all see him in different webinars, live lectures, and we all know him for your contributions in this industry, in the field of bridge engineering, and how he's delivering his lectures in detailed lectures for this on this topic for the students and for the you can say professionals as well. So he's a design expert in the field of bridge engineering, currently working with Tendon Consultants Private Limited, and he has worked in notable projects like RVNL Kolkata Metro and different other metro and bridge engineering projects. So I won't take much time, and I would like to request Vikramji to start his session. Over to you, Vikramji.
Yeah, so I hope my correct screen is visible to all of you.
Yes, yes, yes.
Okay. So good evening, everyone. I hope your day has been very well. For today, it's Saturday. Maybe most of you had a working day today. I had a leave, holiday. So I was just preparing for this session, and I hope you will find this webinar and seminar up to the level and extent which you intend to perceive from this session. Today, we are going to deep dive in the session for a bridge engineering. This is not about the deep design. How do we actually work in the consultancy? This webinar is primarily all about how do you as a beginner or as a fresher, you can join this industry of bridges. When we perceive the two fields, especially the bridges and building in terms of design, let's say when you come fresh out of the college, you probably know about the three things: bridges, buildings, or highways. Later on, when we continue working in the industry, that time we come to know about the chemical industry, petroleum industry, the infrastructure industry, or water effluent treatment, water treatment. There are a lot of companies which are working in the civil engineering domain, but we are primarily thinking about the bridges and buildings. So out of those two major fields, today we are going to discuss about the bridges. Although we have a lot of topics to be discussed today, but we will stick to some of the major topics because we do not have a lot of time. So we will start with what is meant by bridge, what has been meant by bridge, what do we mean by bridge in the today's era. Then what are the different kinds of software, the different length for which you will be designing the bridges. Then what are the importance of the bridges, importance of bridge engineer itself. Then different types of construction methodology and the different types of roles of different engineers in the bridge engineering, or you say in the bridge construction. Then we will think or we will see some of the opportunities available in the bridge engineering industry, and some of the references I will explain to you. although Sandip sir has already discussed about the instructions to be maintained during the session, but once again, I would like to highlight what are the some specific rules to be followed, especially. If you have any questions, I will humbly request you please note down the slide number, which is mentioned on the right bottom, so that you can ask your questions at the end. And please sit in a mild disturbed or very, very silent zone, because this session is not just a basic one. Even though it may be basic for me, but you are going to learn a lot of things in this session. And I will request, please listen. And this session, you will, maybe Sandip sir will upload this on YouTube also. Yes, sir?
Yes, it will be uploaded on YouTube later on.
Yeah. So I will humbly request to everyone that you listen the audio, you understand the concept. If you have any doubt, you ask at the end, because you will get this video at the end on YouTube available. So you can watch it any number of times. But that time I may not be completely available for the questionnaire. Okay. So what is meant by bridge engineering? So let's see a video which will explain you a bit of bridges. Although you are completely aware of what is meant by bridges, but the purpose of this video is especially to explain you what is the extent of bridges which we have been working on, or I have been working on. So just for the confirmation, I hope the audio of this video is also audible.
No, actually, only the video is visible.
I'm not sure how to make it. Okay, just give me 1 second. I will try this if it can be possible. Audible now? Audible now?
No, actually, I think your system audio settings need to be changed.
Okay, it's okay. Just try to see this, and even if it is not audible, at least you will get the visuals here. I will just skip this video in a few seconds only. See, this is the extent of bridges we are talking about today. This bridge, which is shown here, this has a width of 28 meter. The depth here is actually 6.7 meter. And the width of pier here is actually 4.3 meter. So this is the extent of bridges which you will be working on when you join the bridge engineering industry. I will not say you that this will be the first project you will be working on, but these are the type of project which you will be encountering in your career. And believe me, designing and working on such kind of projects has been really a good experience. But for that, you need to work on several types of projects, several spans, configurations. Only then you will achieve the level where you will start working on these type of structures. Okay. And when we talk about the span of this bridge, this was actually 125 meter. So one pier is here, second pier, and the span is 125 meter here. So this is the level of extent which the bridges are constructed. Not always like the 20 or 30 meter span which you generally see. But these bridges are highly special. So we need a special experience to work on these type of structures. You can see the distance between the piers here also. So this bridge is located over the river Brahmaputra, and the bridge is connecting the two states, not only two cities, but the two states. One is Assam and Meghalaya. And the project name is 𝗔𝗰𝗱𝗀𝗰. You can just search on the Google 𝗔𝗰𝗱𝗀𝗀 latest update. You will get ample number of videos to explain you about this project. So this has been the scope of the project. There are some dimensions given just to understand. The span is 125 meter. The height of upper pylon is 18 meter here. The lower pylon is 16.7 meter and the foundation was actually well foundation with a total depth of 37 meter. And the dia of well foundation is 11 meter. So this is just a glance about the bridge engineering, the type of project you may be encountering. Let's move ahead towards the real bridges. Just give me a second. Yeah. So what is a bridge? Generally, we say there is a bridge, this is a culvert, this is a causeway, this is vented causeway, there is a flyover. So what is meant by a bridge? In general, all those structures which you see in general, which we have a different nomenclatures, all those are called bridges. But what is meant by bridge in general? So in general, the bridge is the way of connecting the two places. As a bridge structure brought forward under construction to surpass an obstacle without affecting the properties of the obstacle. So let's say there is a bridge or let's say flyover, it is connecting from one place to another. So you don't want to affect the properties of this river channel or sea. That's why you are bringing a bridge. If you could alter the properties of the obstacle itself, then you don't need to construct a bridge. If you just fill the soil strata over here, then you don't need any kind of bridges, right? So there are different categories technically in the bridges itself, but in general, all those structures are called bridges. So in this figure, this is a metro station. The metro will be running here. These are the two tracks, and this is a cross arm for the stations. So this is one cross arm, second cross arm, pier 2, pier 1. It is connected, and this structure is also called a bridge. In metros, we call it a viaduct or a station, but in general, we call this one also as a bridge. In general, the complete whole word. Just like whether you are working in the design of bridges, buildings, water effluent, chemical, any industry, but everything is RCC or steel. So in general, these are called the bridges. In the past or ancient era, we had the natural bridges. That time human did not know what is meant by cement, concrete or steel or how to construct a bridge. So the wooden arms which fall down on the ground, the humans connected all those branches and they formed a structure to pass this water carrying channel. So in general, this is also called as a bridge. Then when they got some mindset to learn the thinking capability, then they brought and constructed a rope bridge or rope plus wooden bridge. And now you see the different types of bridges in the different locations and areas. Depending on the location, be it valley or it is plain ground, it is hilly ground, or it is Registan or anywhere, depending on the location, there are different types of bridges which are constructed. In the modern era, we have different types of bridges, but in general, the bridges are divided into 6 categories. The 6 categories, each and every bridge may fall into 2 or 3 different types of categories, but that does not mean it is only simply supported or arch bridge. For example, in general, we call this as truss bridge, right? But it is resting over the bearings. So this is also termed as simply supported bridge. So this same bridge is falling into 2 categories, simply supported bridge and truss bridge. Okay. And at the bottom, this is suspension bridge. And on the bottom left, it is cable stayed bridge. So in today's era, we have different categories of bridge. And if I name some of them, this is 𝐃𝐨𝐬𝐝 in Hyderabad. This is DMRC, Delhi Metro Rail Corporation Viaduct. This one is under construction. Delhi Mumbai Expressway. This is still under construction. And this one is Nagpur Metro. So all the figures given here are the real life example of the bridges. Then when you talk about the general bridges, see, when we are working in the industry, we have different types of nomenclature. When I'm designing the bridges, I don't even care whether it is longitudinal girder, abutment, cross girder, or pier. We don't see these kind of figure. This is an academic figure. When you start working in the industry, this is a type of figure you will see. Okay. But in general, when you are starting the journey in the bridges, when you are asked the questions in the interviews, they will generally refer to these types of figures. Why? Because the freshers or beginners, they have been through the academic books only. They are not industry experts. They have not been through the industry. So as personally, if you talk about myself, I don't expect anyone that you know about the bridges already. One of the major question which I receive generally from the beginners, that if I go to appear a bridge engineering interview, what kind of questions they will ask from the bridges? Means, are you seriously looking for the interview for the bridges? Because if you are going for the bridges interview, the person who is taking your interview, they don't expect you to know even A or B of the bridges. Because even I was going through the masters, I did not have the bridge engineering subject in my academics. The bridge engineering, generally 99% cases, the bridge engineering syllabus is not available in the academic curriculum. So the interviewers also don't expect you to know the bridges even before working in the bridges. Okay. So when you go to the interview for the bridges, don't expect that they will ask you the questions from the bridges. They will ask you the questions same as when you go to the interview for the buildings itself. Because in the colleges, we have studied RCC and steel only, not the bridges. Okay. So even if they ask you a bit of questions from the bridges, then they will hardly ask with reference to this figure only, because this is the best figure you can find in any of the book. And this figure is taken from one of the very, very famous book, Essentials of Bridge Engineering, written by DJ Victor. When I started my journey in the bridge engineering, this was the first book I was referring to. And believe me, this has been one of the best book for the basics to intermediate level in the bridge engineering. Then there are different types of bridges. Some of the bridges have pre-stressed eye girder. Some of them have pre-stressed box girder. Some of them may have steel girder, plate girder. Some of them may have trusses. If you are aware about the Mumbai-Ahmedabad high-speed rail, then it is being constructed over 40 meters single span. The single entity of 40-meter length. This is one pier. Second pier, they just bring one segment of 40-meter length with 3-meter depth, which weighs around 1000 to 1100 tons. So they are carrying big machineries to construct this structure. And along with this, you will find several types of PSC girder, box girder, and steel girder or the truss bridges also. Okay, depending on the suitability of the location. Let's say you are constructing a bridge over a busy highway. Then you cannot stop the traffic. So you have to bring forward one of the solution for which you do not need to stop the flowing traffic. Okay. So they brought forward the steel truss bridge for that. As far I remember, it had a span of 135 meter. Hello. Hello.
Yes, Vikramji. Yes, Vikramji. We are. You are
Okay.
audible.
If I skip somewhere, please inform me, because I'm getting a sound like my internet connection is not stable.
No. You are audible. Completely
Okay.
audible. No problem.
So when you are constructing the bridges, The first and foremost question I may ask you, or someone may ask you, or someone may ask me itself, that I have 1 kilometer long flyover. What kind of structure shall I suggest? It shall be concrete slab beam. It shall be RCC T-beam. It shall be PSC girder, box girder, or it may be extra doors, cable stayed, or suspension bridges. The longest suspension bridges right now available in the world has a span of around 1900 meter. The clear span between the two piers is more than 1900 meter. I'm not sure exactly about the value. It may be around 2002 meter something, but this is the longest span. So let's say if I'm going to construct a 5 kilometer long bridge, I can just construct the 2 or 3 span only. No need to go for 100 or 500 number of span. But why we do not go for such bridges? Forget about the suspension bridge. People are even scared of cable stayed bridges and extra doors bridges. They are hardly going for box girder, PSC girder. They hardly go for RCC T-beam or concrete slab. But most of the bridges and flyover are constructed with the PSC I girder and box girder. But why? So when you go to the economic study of the structures, especially in the bridges, you will find that if the material are available on site, that means, let's say you are constructing a bridge in Jammu Kashmir. Jammu Kashmir does not produce cement, concrete or reinforcement. You have to carry it from somewhere else. Is it really possible to carry all the materials at the site location? Considering the terrain there, it's very, very difficult, right? So what we do, based on that location, you may be required to construct a cable stayed or suspension bridge. But you will find that all the metros, all the flyovers constructed between the cities are always constructed 99.9% probability that the flyover within city, be it metros, highways or railways, are constructed over the box girder or PSCI girder. Because considering the availability of material, these are the two best, most economical options. Now, how do I know this? Because I have worked in this industry. How you know this? Because you have gone through the academic books. So books will tell you these types of questions and answers. So when you are going to face interview in the bridges, these are the kind of questions they will ask you, that if I give you a span of, let's say, 30 meter, then which kind of material or span or a type of structure will be more suitable. Okay. Now let's say you are going to design a bridge or for the PSCI girder. See this, just one minor error on the construction site and the entire span fall down. That's the importance of engineers, be it design engineer, site engineer, or safety officer. All of them are important given on their specific roles and responsibilities. This incident might be avoided if the engineer was there to guide the levers, to guide them how to construct this kind of bridge, or not just construction. There are small activities which may lead to disaster on the site. So engineers shall be there to guide the levers how to handle the different types of component. Okay. Although nobody want to lose their life, they are already taking care of each and everything. But labor are not engineers. They don't know the implication of each and every component on the site. So you are there who are aware of each and everything in this field. I'm not saying that you are a fresher and you shall be aware of 100% everything, but you are also guided by the seniors. So you learn from them and guide the laborers what facts or rules you have to remember while constructing or handling this component, right? See, This is one more case of falling girders, PSC girders falling on the ground. Just keeping on the pier cap and girders fall down. That's it. The deck slab is not casted, no vehicles, nothing. The girders fell by its own self-weight. Okay, so when there is any allotment of the project, there is not only a single authority. There are different types of authorities who will be working for single project. So there will be one client. Let's say there is a highway project and client is NHAI. NHAI will allot the project to some contractor after the bidding process. Bidding process is a different procedure. You can just go to Google and find out what is the tendering process, bidding process, all those things. I'm talking about after the allotment of project, how the work flows. So NHAI is one client. They want to construct a bridge. So what they will do, they will allot this project to a contractor. Contractor will bring all the materials, machineries, and they will construct the bridge. But contractor does not know the design. So who will do the design? Contractor will hire an authority who will make the detailed design of each and every component. And that authority is called Detailed Design Consultant, DDC. And this DDC is hired by the contractor. Now, how to make sure that DDC is working at the 100% accuracy? So there shall be one more organization which will make sure what DDC is doing is really correct. So contractor will hire one more organization called Proof Check Consultant or PC. So PC will check the designs prepared by the DDC. So contractor will give the design to DDC, which will be proof checked by the PC. Now, how the client or NHI know that the contractor is really doing a good job? The DDC or PC who the contractor has hired, they are really doing the work at the 100% accuracy and following all the guidelines prepared by the client. So client will hire one more authority called authority engineer or AE who will proof check the job done by DDC and PC. So even in the design, this is not just one job. If I talk about myself, I do my design, then my senior will check it, manager will check it, means three people are checking at the DDC level. Then it is being checked by one engineer in PC and one senior in PC, 5 candidates, and now it is going to AE. Do you really think it is even possible that a bridge fall down under construction? It is very, very rare because it is checked and designed by 3 companies and several levels there also. There are 10s, 20s or 30, 50 number of people who have worked on this design. And still if the structure is failing, personally, I don't believe that it failed because of the design failure. Maybe there are different types of incidents happening on the site, but from the design part, I make sure that a structure does not fall down. Then after all the authorities and engineers have verified the design, at the end, they will produce a drawing which will go to the contractor. Now contractor will go to the client, get the drawing signed and go on the site and construct the structure. This is a general procedure which is followed in most of the project. Not all, most of the project, because this method of construction or allotment of project is called EPC, Engineering Procurement Construction. Most of the bridge project or highway project are allotted on EPC mode. Some of them are on the item rate or lump sum mode, maybe depending on the scale of the project. But NHAI is allotting more than 99% of the projects based on EPC mode. NHAI is working under MORTH, MORTH. So both NHAI and MORTH are following the same EPC mode of allotment of the projects. Then when you go to the construction industry, we call it AEC. AEC industry. A for architecture, E for engineering, and C for construction. And out of this entire industry, you are working in the engineering domain. And out of the entire engineering domain, I am working in the design engineering. Someone else may be working on the site engineer. Someone else may be as a PMC. So there are different types of role in each category. Okay. In fact, all the organization here, DDC, PC and AE, they all fall in the category of engineering only. And that too in the design engineering, not to the site engineering or the construction. Because on the construction, they have other engineers. So if you're going in the bridges, not in the bridges, if you're going in the buildings and metros, you will have architecture available with you because the buildings and metro stations cannot be constructed without the consultation of architecture. So architect is not as such useful in the highway bridges, but it is compulsory in the metros and buildings. Then after the architecture, it will go to the engineering. Engineers will do and perform their analysis, design, then drawings, and then the drawings will go to the construction. And on the construction, that is a real product of AEC industry. The actual product of the entire construction, which is being constructed on the site. Let's say there is a metro station constructed in DMRC. Nobody know who was the architect. Nobody know who was the design engineer. Even they don't even know who was the site engineer. They just know what is constructed there. It is a metro station. That's all. Nobody care about the engineering. But there is a lot of hard work going behind the scenes, which makes sure the structure is stand throughout its entire life. The life of structure may be 50 years for buildings. It is 100 years for the bridges. Some of the structures are constructed for 80 years or 120 years, depending on the requirement from the clients. So each of the category have its own implications. Now, coming to the softwares in the bridge engineering industry. There are different types of varieties of softwares available in the bridge engineering industry actually. There is not only one software which I can say you that you learn this and your job is done. There are number of softwares available in the industry, but each software has its own method of uses. Let's say you are designing a small span bridge or just a 20-30 meter RCC bridge, then STAAD Pro is sufficient for you. You don't need to go for any other software. And I'm pretty sure you know the cost of the softwares. I will not tell you directly here, but if you are already aware about the software cost, then you will understand one most important thing, that if you are working on a small scale project, you will utilize only STAAD Pro, no any other software. Why? Because the cost of license for other softwares is very, very high as compared to STAAD Pro. Okay. So when you are going to design a small span bridge, STAAD Pro will do your job. When you are going to design a 40, 50, 60 meter bridge, then you will be required to use a Midas Civil. It's not compulsory. You can use the Excel sheet itself and do your own manual calculation. That's all. But if you want to take the advantage of softwares in this industry, then Midas or Sophistic will be your next choice. Now, what about the other three software? Other three software are not as such used in the Indian market. Most of the industry is taken care by the STAAD Pro because it's not as costly as other software. Midas Civil as of now is dominating the market, and software Sophistic is also standing in the market, but it is not widely used. Sophistic has been very widely used in the European market, but not in the Indian market. There are certain consultancies which are using the Sophistic software, but let's say there are 100 companies, then maybe 95 are using Midas Civil. Or let's say that if there are 100 companies, then 60 or 50 are using STAAD Pro. Remaining 30, 40 are using Midas Civil, and hardly 5% are using the Sophistic software. But remember one thing, if you're going to join the bridge engineering industry, unlike the building design, Software are used for analysis purpose only in the bridges. In the bridges, the softwares are not used for the design. Design is done in the MS Excel with manual calculations. So when you join the bridge engineering industry, you have to learn one of the major thing, that is MS Excel. And learning MS Excel is not a big deal until and unless you don't want to learn it. If you just want to learn certain formulation in the Excel, believe me, designing a bridge is not a big challenge. Designing a bridge is not a big challenge. That does not mean it is not, or it is easy to analyze. The biggest challenge in bridge is the analysis, not the design. Okay. Now, why we don't use the software for the design? Because there is at least one amendment published in the code every quarter, and softwares are not that frequently updated. So what if there is an amendment, it is not updated in the software, then who is responsible for the errors which is there between the code and the software? So in general, in the bridges, we use the Excel for the design and software for the analysis. Now, this is StatPro software. This is the Connect Edition version of the StatPro. It is just a first window what you will see in the StatPro. All the options are available here for the design. For the modeling, all the options are available in the main menu. Then this is a workspace, node tab, element tab. We call it workflow in case of StatPro. But if you go to the Mida Civil, the same menu is called tree menu. On the top, you will find it as tree menu. All the job you are performing in this workspace, everything will be listed out here in the two tree menus. Any error warning that you will find in the message window, and the same for the modeling, analysis and design. There is a main menu and all the options are available within itself. You can even see that within the main menu view, there are a lot of options, and within these options, there are drop down arrows also. See, drop down arrows. So there are a lot of options inbuilt within the options itself. Okay. See, lot of drop down menus. So when you are learning the software, it is not about the engineering, or when you are learning the engineering, it is not about the software. Software and engineering are two separate things. Now, why we are using the software, or is it really separate thing? No. Then where is the connection? You are the connection. Means that you are the engineer, you are doing the design engineering. Software is produced by another company, and now it's your responsibility to bring the design in the software and utilize the software at its 100% full scale, considering to the point accuracy. Sandip sir has always been saying, if you input the garbage in, you will get the garbage out. So if you want to get the correct results, you have to make sure your inputs are correct, because software is doing its own job. Are you doing your job? And your job is not just about writing A equal to B or B equal to C. Your job is to understand how the Excel work, how the software work, how the engineering work, how to get the detailing designing. One more special thing I will explain you right now, that I have been listening some roles in the building design. There is one special person called detailer. In bridges, there is no company who is hiring the detailer is separately. If you are the engineer working there, then you are responsible for extracting and gathering all the raw data, making the software modeling, putting this in the Excel, making sure your design is correct. You have to verify your own design, make sure to give this data to the draftman. And when the drawing is produced, you are responsible to check that drawing. Not only up to the level of your input is correct or not. You are responsible up to the scale whether the detailing is correct or not. There is no third person between you and your draft person to check whether detailing you have made is really correct or not. If you ask me about myself, I gather data, I design the metro station, I do and perform each and every check, be it pile foundation, pile cap, lower pier, upper pier, mid pier, the pre-tension girder, post-tension girder, track girder, normal girder, the station's washroom, equipment room, every check I have to perform. Then I will give my design data to the draft person, and this draft person will make the drawings, and only I am responsible for the accuracy in the drawings. No third person. Okay. So that is the level of learnings you will get in the consultancies. So you have to be responsible, and you have to make sure the structure which you are designing is standing throughout its intended life. Then the third software, it is the sophistic, which is making its feet or standing its feet in the market and started a few years back. When you start learning the bridges, just like the buildings, we have different types of design codes in the bridges. Comparing your IS 456, IRC 112 is a mother code for the bridges. Let's say I write different types of comparisons. So IS 456 is equal to IRC 112. IRC 6 is equal to your loads. So you have IS 875 for the loading. IRC 6, we have the loads. Then IRC 5 is for the standard specifications. Just like when you are going to design a building, there are certain norms that your height of building cannot be more than 4 floors or 5 floors. Your floor index area cannot be more than certain value. So all these guidelines are assigned in IRC 5. Then IS 1893 is equivalent to SP 114. That is a design code for the seismic design of the bridges. Then for the steel, you have IS 800. In IRC, there is 22. At the place of IRC 78, it is for the foundation. We have 2911. Then explanatory code for the highway bridges. We have SP 105. And in IS, we have, I think, SP 34. Then there are different types of codes required based on your design requirement. So when you start working in the bridges, IRC 6 and IRC 112, these are the two basic code. These two are the basic, intermediate, advanced, and top level code. Means be it any kind of bridge, these two code will always be there, irrespective of whatever you are doing. Whether you are designing a box culvert, multi-cell box culvert, single span bridge, multi-span bridge, cable straight bridge, PSC gutter bridge, box gutter bridge, suspension bridge, anything, IRC 6 and IRC 112 will always be there, because all the loads for which you will design are given in IRC 6, and all the design procedure will be followed through IRC 112. Then there is a construction industry. In the construction industry, we have a lot of categories available on the site. There is a billing industry, means billing engineer, site engineer, estimation engineer, or the bar bending schedule engineer. There are a lot of categories. I'm not exactly sure how many engineers are working there or what are the different types of categories are working on the site. But some of them which I know I have explained. But believe me, the job which you are looking for, the design engineering, as far I have experienced it, it is, I will not say it is easier, but comparative to the site engineering job, it is really easy. Because there has been a lot of cases which are where the site engineer want to change their job to the design engineering, but I am not aware of any engineer who is working on in the design field and want to shift to the construction side. So in my opinion, the construction of a real product is far more difficult. There are different types of challenges which you will face on the site. We will discuss it later. So when you are going to construct and execute a PSC gutter, there are different types of stages. Okay, so you will place your reinforcement at the location, different types of reinforcement based on the requirement. Then you will put all the shuttering for the construction of the girder. Then after construction of girder, you will pre-stress it, because when you go a span more than 20 meter, which is a general case in the industry, most of the structures are pre-stressed concrete structures. It may be PSCI girder bridge or box girder bridge, but most of the structures are pre-stressed concrete bridges. And that has been the most economical form of the structure in the today's era. Given that the location is not prevailing, like the example we have given before, if you are constructing a bridge in Jammu Kashmir, then PSCI girder is nowhere economical. Okay. Then what you will do after that, you will place the girders on site. Then you will cast your deck slab and the construction is over. In the same way, all the procedures which you have to follow on site. So there are different types of jobs you have to carry out in the on the design field. If you are more interested to learn the what are the procedure to be followed on site, we can discuss it later. Let's see one of the video they have followed on the construction site for the construction of box cutter bridges. This passion for the bridges is one of the best YouTube channel where you will learn a lot of things about the bridges, how to construct a bridge, that you will learn for sure from this YouTube channel. Please note down this channel, Passion for the Bridges. So this video is also taken from their YouTube channel only. So the major point of highlighting this video was the type of machinery that is being used on the construction site. Construction of a bridge is really far difficult because of the machineries which are involved in the construction. Although there are a lot of problems you will face on the site while constructing a bridge, but machinery has been the major challenge. And coming to the challenges, then depending on the level of the project or the scale of the project, there are different types of challenges you will face at each and every level. So when you are going to the design, you have to check whether it is pre-stressed concrete, what type of local failure it may be there, what are the different types of site constraint, because what if site engineer does not want to go for the pre-stressed concrete, even for 50 meter span, then what? You have the second option to go for the steel plate girder. What if you are going to construct a long span bridge? Long span bridge is a separate category. Even thinking about the long span bridge has been a major headache for any engineer. And coming to the construction, you are going to bore for the pile. What if your borehole collapse? You are going to construct a bridge under the water, just like in the sea, MTHL, Mumbai Trans Harbour Link. It is constructed in the sea. So there is a different next level of challenge. How to ensure the quality, the activity schedule, and the leveling of each and every component. Because if you don't maintain the leveling, the right quality is compromised. Then higher grade of concrete. If you are going to join the bridge engineering industry, forget about M20 and M25 or M30. Any of the PSC girder, any kind of pre-stressed concrete bridge is not constructed below M40. M40 has been the major minimum requirement for construction of the bridges. I have not seen anywhere below M40. Although I have seen up to M70, but never below M40. Then maintenance of the heavy machineries, because there are Lot of machinery involved on the construction site. How to maintain all those machinery? There is called hydra, cranes, launching entry, the transportation of elements. How to handle all these machines on the site? That's a big challenge. Then maintenance of the bridges. Environmental constraints may be there according to sustainability, water bodies. Let's say you are constructing a bridge in the sea. There may be one more organization coming from the environment and say it will disturb the marine life. You cannot construct a bridge. Then what? All gone. The project you have planned for years is gone. Nothing. So all the clearance you have to make sure you get from the respective bodies. Then there is special organization, Indian Railways Bridge Management System, which take care and maintain the bridges for the railways. Then socio-economic constraint, the cost, impact, and the benefits it will make. Then challenges in the bridge engineering industry. See, you have to construct a bridge, but how you will dig down and construct the piles? Because unless you finish your piling, your structure cannot stand. So what is the challenge, or how do you solve it? You make a coffer dam. Okay, so that's how you will excavate for the piling and construct the bridge. Then this is not just about the designing. What are the different engineering involved in the bridges? The hydrology. When you are constructing a, let's say, box culvert, this box culvert is used to allow the water flow below the traffic. That until unless you know the availability of water, what is the catchment area, what is the runoff, how much cusack you will get, which you have to allow through this box culvert, then what you will do in the designing. So hydrology has been the first and foremost department. Along with that, there will be the highway engineer, which will make sure all your notations, the boards, symbols, everything is intact on the site wherever is required. Then the mechanical engineer, because all the machinery you are using on the site, what if there is a failure in the machinery itself? After that, you need the geotechnical report. Who will give it? Geotechnical engineer. You need the bearing capacity of soil. Who will be there? The geotechnical engineer. Means geotechnical engineer is also the prime engineer even before the designing of bridges, who will make sure your structures stand for its entire life. Then if you need the complex design of foundations, structural engineer, where the structural engineer cannot design all the structures by its own, you will need the geotechnical engineer. And all the local failure of the earth, you need the geotechnical engineer. Let's say this is a hilly area and you need to construct a highway here. What you will do? Let's say this was a correct slope. What you will do? You will cut from here. Now what if this structure fall down? This rock or the soil fall on the left? What you will do? So geotechnical engineer will be there to make sure the area required for the movement of traffic is always there or always available there by anchorages. So it's the responsibility and role of a geotechnical engineer to provide sufficient space for the highway engineer. On the right, you will see the stepping. Who makes sure this stepping does not collapse? Geotechnical engineer. Okay. Now coming to the career opportunities in the bridge engineering industry. So first and foremost question, which everybody has, is it really worth pursuing? You can go to the buildings, you can go to the bridges, you can go to the highways, you can go to the environment, geotechnical, hydrology, you can go to the petrochemical industry or water treatment, water effluent treatment, you can go anywhere. But is bridge engineering industry really worth? And yes, not a big yes, a small yes, based on your interest. Then what are the things you have to make sure you are aware of before joining the bridge engineering industry? If you are curious to know what is running behind those panels, which panel? These panels. If you want to work on the complex and challenging projects in the bridges, there is a big challenge in the tall buildings. It is there. Similar to that, there is a big challenge in the bridges. If you want, and if you are amazed by the large scale mega project, if you want to explore the infrastructure in the entire world, the bridges which you are restructuring or designing or constructing, this is not just one book you will learn. You will go through, you will learn and design the structure. It is never possible. You will attend and join the conferences conducted by the international organizations. You will be joining and learning from the books written by foreign authors. In fact, I have been researching through the code for Canadian, European, Californian, Australia, American, all those codes to design my Indian structures. So if you want to explore the infrastructure industry throughout the world, and if you want to earn the salary, I'm not saying that the salary is only available in the bridges, but as far I have been aware of the industries, the different industries, the freshers say that the salary structure is slightly better in the bridges. I will not say you are getting 20,000 in the buildings and you will get 40 in the bridges. No, it is never there. Maybe if you're getting 20 in the buildings, you may be getting 22, 23 or 25 in the bridges. There is slight difference. It is not a big one, but it is there. If you follow all these facts, if you are curious about the panels, if you are amazed by the large scale projects, if you want to work and explore the infrastructure project, then yes, bridge engineering industry is waiting for you. The small structure which may be seeming to you, this is actually 30-meter wide. It does not look, but it is. Can you see anything through this janjal? Nothing. This is the level of reinforcement you will be putting in your structure. So there are a lot of things which will be amazed when you join this industry. Now, do we really need masters in structural engineering? Maybe. But is it really required? No. If you want to join the bridges, masters is not compulsory. And it is not said only by me. You can go to the LinkedIn and find out this person, Muhammad Atif Nawaz. He is working in Atkins right now. He has worked in the buildings already for the 4 years, and now he has been working in the bridges for the last 2 or 3 years. And he has given this statement that masters in structural engineering is not compulsory if you want to enter the bridge engineering industry. Okay, you can just search for this person on Google, on Quora, on LinkedIn, on YouTube. You will find him everywhere, and you will find this similar statement at every platform that masters is not compulsory to join the bridge engineering industry. It is not compulsory, but what if you have a master's degree? You will get certain advantage over the bachelor's. Why? Because if you are specifically interested in the design part, then after RCC and steel, what we study in the bachelor's, you have studied the dynamics also. So that will give you an added advantage. But that does not mean master's is compulsory to have a job in the bridges. Okay. Then there are different roles and responsibilities which are assigned to an engineer if you want to pursue the bridge engineering industry. So let's say you are not aware of anything in the bridges, Or let's say you are not even aware of anything in the buildings. You are not even aware of anything in the civil engineering industry itself. You just went to college, get your degree, and pass out from there even without knowing what is meant by civil engineering. If you lie at that level, if you really lie at that level, then what you can do is start from a local bridge design consultancy, or you start from a local site consultancy, or you start from a site engineering job. At least you start your job, because until and unless you are experienced enough to work over certain kind of project, the second company will not hire you. Let's say you want to work in the metros. You don't have the experience of metros. No company will hire you. Then what you can do? You start with local design consultancy, local construction companies. At least you start from there. Then with reference to your experience, you will get the job in different companies. You gather the experience in any design engineering field at least, so that you can achieve a big height in different organizations. And if you are really interested that you want to pursue this field, you are not looking for site engineering or anything else, then yes, pursuing masters may be one more option for you. What are the roles of a bridge engineer? You may be a structural engineer. And as a structural engineer, this is not just a design. There is a coordination, there is a detailing. Although most of the companies do not have a separate engineer for the detailing, but as a structural engineer yourself, you have to be aware of the detailing itself. Then there is a BRIM. Just like you have BIM in the buildings, building information modeling, we have BRIM in the bridges, bridge information modeling. So drafting, modeling, coordination, anywhere you can enter in this field. Then coming to the construction, you can go to the site engineer job, coordinator, QA or QC, or billing, estimation, anything you can enter. Which field of bridges you shall be choosing from? When we talk about the bridges, it is not just highway bridges. There are railway bridges. There are metro viaduct. So when you go to the metros directly, metros follow a certain level of strictness. Companies which are working in the metros may not be hiring you directly. So what you can do, you can work in the highways, then you can shift to the metros, or you work in the railways, then you shift to the metros. Or if you're getting a job directly in the metros, believe me, that is the best. But that does not mean metro is the only field. Personally, I love highway bridges, not the metros. I'm working in the highways, I'm working in the metros. I have worked on the viaduct, I have worked on the stations, I have worked on the substructure, superstructure, foundations. But from the bottom of my heart, I love highway bridges. That's your personal choice. But as per the codal provisions, the strictness that will be followed on the structures, or let's say if there are 100 bridges, out of them, let's say 5 bridges collapse in the highways, you will hardly find even a single bridges from the viaduct collapse. That is a level of accuracy, the strictness or perfection metros make sure in their structure. That's why a lot of people are there who want to join the metros because of this single reason. Okay. Then coming to the certification, do you really need a certificate in the bridges? So as we have already discussed, as an interviewer, if I'm taking your interview, I don't expect you have any knowledge in the bridges, but I expect that you have certain level of knowledge in the buildings at least, because that is what you have studied in the colleges. So certification is not compulsory. It's not recommended that you pay lakhs of rupees and you take a certificate. But yes, if you have a certificate, it will give certain advantage. Not 50% or 100% advantage. It will give you, let's say, 2 or 5% of advantage over the others. Okay, so neither masters no certification is compulsory to become a bridge engineer. Although if you have, it will just give you certain advantage, maybe 2, 5 or 10% max, not more than 10%. Then coming to the BRIM, just like the building information modeling you have, there is a software called BRIM or CIM actually. CIM is a software developed by Midas Civil company. The software which we have already discussed in the back, StatPro, Midas Civil and Sophistic, CIM is developed by Midas Civil. So let's see this video that you will understand how CIM can be used in the bridges. So Midas has been one of the best company to provide its software called Midas Civil. And after the Midas Civil, they have provided Midas CIM, Midas Finite Element, Midas GTS. There are a lot of software as a family in the Midas company. So based on the requirement, you can follow any of the software. Then some of the tips and tricks that I can share with you for the interviews when you are appearing. I'm pretty sure that you do not have any level of knowledge in the bridges, but you shall have the basic knowledge of design, especially IS 456-2000. Okay. And if you understand the IRC code, that will give you an added advantage. But that does not mean you will be hired. It will give you the advantage because designing is a primary thing. If you know IS 456 design, that's all, because the design of bridges and buildings are similar. Similar in the way, if you have bending moment in the buildings, you will not call it torsion in the bridges. Bending moment will remain bending moment, shear force will remain shear force. So design procedure remains similar in both the code. You shall be aware of the construction activities because these are the basic things which are expected from anyone, irrespective of whether you are going for the interview in the bridges or buildings. But in the bridges, since piling is one of the major factors, so you shall be aware of what is planning, scheduling, piling, BBS, billing, costing. These are the basic thing you shall be aware of in the bridges, especially when you are going to the site engineer job. Then for the site engineer job, drawing reading skills is a prime. You cannot avoid it. Also for the design engineer job, if you don't know how to prepare a drawing and what you are doing in the design, because at the ultimate, drawing is the only thing which will reach to the construction site. Your design will not. If you write A equal to B, that will not reach to the construction site. On the construction site, you have to share your drawing only. So both the site engineer and design engineer shall be perfect in drawing reading. Because until unless you know the drawing reading, as a design engineer, do you really think you can prepare the drawing? In fact, in the drawings, there are different types of drawing. General arrangement drawing, numeration drawing, reinforcement drawing, general notes drawing, pre-stress drawing. There are different types of drawing. You shall be at least having the basic skills of reading the drawing. If you're perfect in that, then you will have a better advantage in the interviews. The basic understanding of the structural engineering subjects, it is the basic funda for the bridges. because in the bridges you have not learned in the academics, so you are not expected to be aware of the bridges in depth, but you shall be aware of the basic mechanics, SOM, RCC, and the TOS, the theory of structures. Then you can widen up your skills by attending the seminars, webinars in the bridge engineering industry. Then understanding of pre-stressed concrete concept. You have to make sure you know the pre-stressed concrete bridges if you're directly targeting the big level of companies, the MNCs or the big consultancies. If you're targeting the bigger level of companies, then they are also expecting the bigger level of skills you have. And what is the bigger level of skills in terms of bridge engineering? That is the pre-stressed concrete bridges. As I have said already, more than 90% of the bridges are constructed of pre-stressed concrete. Okay. Then what are the references to learn the bridge engineering? You can follow the book. In fact, the figure I was showing you in the beginning, that was taken from D.J. Victor. And this is the best book if you are starting your career in the bridge engineering. If you are a beginner or fresher, please follow the Essential of Bridge Engineering written by D.J. Victor. This is one of the best books you will ever find in the bridge engineering industry. Then coming to the pre-stressed concrete bridges, or let's say normal pre-stressed concrete, that you can learn from the N. Krishnaraju pre-stressed concrete book. Then coming to the in-depth fundamentals about the bridge engineering, you can follow the fundamentals book written by Wi-Fi Chen and Lianduan. That will give you the most basic fundamentals. But remember one thing, this book carries all the concept highly in depth. So reading this book will take you months, and it is not written by Indian author also. So understanding their accent of writing and concept will again be difficult. So better you start from the first book, DJ Victor, then you move forward to the different books. Coming to the online courses, Indian Association of Structural Engineers, IA-STRUCT-E, is one of the major organizations available in the field of structural engineering. They provide different types of courses. I have also joined their several courses. You can join their courses to learn from the industry experts. When they conduct a course, let's say they conduct a course on pre-stressed concrete for bridges and buildings. The authors who presented their lectures there, they had experience of 20, 30, 40, 50 years of experience. They shared their experience in the field of pre-stressed concrete bridges. Now just imagine you are learning from the topmost talent in the world, not only Indian. The authors who present their presentations or sessions in these courses, they belong to the world, not just Indian. Okay, so you will learn a lot of things in this course. Then if you are targeting only the bridges, then IABSE, International Association of Bridge and Structural Engineers, then CEAI. IABSE is foreign institution. If you are targeting the Indian institution, then you can join IIBE, Indian Institution of Bridge Engineers, and CEAI, Consulting Engineers Association of India. So based on your requirement and your understanding, you can join any of the organization. I will not you join this organization, but keep an eye when they publish their course, because they publish their course online live courses, not recorded or books. As of now, I have joined one course on retrofitting of bridges by IABSE. It is conducted every Friday, 5 to 8 p.m. So based on your requirement, you can join the different courses produced by different organizations. And it is not always there that they will produce one course in March, February, or what. They can produce their course anytime, anywhere. Okay. So you have to keep an eye over all the platforms to make sure you do not miss their course. Then bridge engineering It is an academic course taught by Professor Pyali Sen Gupta. You can refer to it. This will be the best online course in the bridge engineering available on NPTEL website. Okay. Then differences to learn. Construction site has always been the best reference to learn the bridge engineering. So that's all from my side. One of the major thing which I can tell you right now, even if you do not come to the bridges or you do not know what is meant by IRC 112, but please note down one special thing. The minimum strain in reinforcement before failure as per IS 456 is 0.002 plus 0.87 Fy upon ES. But as per IRC 112, this 0.002 has been removed. What does it mean? If you remove it, let's say we take certain assumption, the reinforcement grade is 550 and the effective depth of section is 500, then actual limiting will change because of this factor of 0.002. How much change will be there? The bending moment capacity based on the different grade of concrete and width of section, you will find that if I take 2835 minus 2310 divided by 2310, let's bring the calculator. 2835 minus 2310 divided by 2310. There is a roughly 23% increase in the ultimate bending moment capacity when the structures are designed based on the different codes. Okay. So that was the final thing I just wanted to convey you. And thank you very much for joining this session. I hope this has been a good learning in the bridges. And if you have any questions, you can ask. Thank you.
Thank you, Vikramji. This is a very detailed program actually. All the information that you have provided, it's really, I'm pretty sure those who are starting with the journey in bridge engineering domain and this kind of session will be really helpful to them.